Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And this week we're going to, kind of dive into the world of firmware. And it's, I guess, well, you want to go on the wonderful, Wizard of Oz trip here of all the different firmwares out there and, kind of see where you go. So, this week I'm kind of let, John kind of lead this one. So, when you're thinking, firmware, what are you thinking about?
I think I'm going to start with what is firmware?
Yeah.
Right. We've been kind of throwing that term around, and if you're in the tech world, you know what firmware is, and you know kind of how important drivers would be. Even these things, they exist so that they can tell your machinery what to do, because you don't speak assembly language or machine, but they need some type of something to work off of. So that's kind of the basics of what firmware is. But when we get into the printing world, oh man, your firmware can do so much. Your firmware can all these manual fixes that we've talked about before, where we adjust it with a knob, or we get a new part, or we get a bigger fan, or we print this so that we don't have this extrusion problem. That could probably be handled in the software, the firmware side of everything. So the first thing that I think is important is understanding why firmware is important, and understanding kind of what your firmware is. So when you start out with a printer, it's going to come with firmware, but I suggest going on to maybe GitHub and searching Marlin and seeing what the upgrade is, and opening up that INI file, that config file, and seeing what it is. If you have any idea what C+ code or anything like that, you'll start reading some and start seeing,
TypeScript.
This is what this calls to whenever it's setting up its code or reading the code. And you can kind of work with your speeds. You can adjust your quality and purely your firmware. So for me, the firmware is absolutely vital. But then again, we talk about it's as vital as an OS would be, right? Yeah. But there's so many different flavors, right? So in my eyes, I'm thinking of firmware as it's my machine code. But on an OT standpoint, what are some examples that you've seen that kind of where firmware dictates how a process works or anything like that?
Well, far as if you're saying how it affects the shop floor,
yeah,
the way it could affect the shop floor is that there are different revisions that a firmware that you would use on, say, a micro controller, or say, for example, PLC, where it gives you some functionality. However, sometimes that functionality may have some type of side effect. So the biggest things with, say, in the OT environment in firmware is you have to be aware of what side effects you have. Maybe not so much with a 3D printer, but normally you gain some kind of advantage with the firmware, some feature that was previously not available.
Okay.
So that's the biggest thing I've seen, is that you get some feature. But as we know, OT and security, you have to be careful and take that with a grain of salt, because sometimes features you get, but you also get some unwanted features also.
Yeah, those are called bugs.
Yeah, that's no, that's a feature. I don't know what you're talking about. It's supposed to.
It's an unplanned feature.
There you go. Yeah, all of our bugs are unplanned features. But okay, so that's definitely kind of what I was trying to get towards. Honestly, from just asking how it affects you in that environment. But then I want to kind of toss it over to Nick and So Nick, I've personally seen you work in Django and build an application. On an IT standpoint, how important is that firmware, and how similar is it actually to Ed's experience?
Ooh, that's a fun one.
That's a big one.
Yeah, that can end up, like you said, the unwanted features, or unpaid for features, will always come back to haunt you with that particular thing. If you think about it, if you start with the one thing that everybody has in their hand, cell phones. When you do an OS update, you're really not updating the OS as much on the phone as you are the firmware version, because that's all it is. It's firmware. Your OS is a firmware. Any which way you look at it, OS is firmware. You start dealing with like hypervisors and stuff like that, like your ESXis, your VMwares and stuff like that. That is a firmware that runs on bare metal servers that can run a virtualized environment by taking advantage of not only the code, but the machine technology that's on board the CPU. And then you start getting like thread ripping and stuff like that. And you start really getting deep into different firmwares, because in the IT world, every piece of a machine, same thing with the OT side. Every machine has its own firmware. And if those firmwares don't talk or like each other, then you have a problem. You may update one firmware on one part, but the firmware on something else might be different, and they just don't talk because the availability is not there. However, you would update that other thing, and then magically start talking again. We've had multiple times of where communication, TCP/IP communication, completely just shut down, and that's mainly because of the firmwares being different. Older PCs run a different version of a communication protocol than newer ones do. Yeah. So that's why somebody says, "Oh, well, it's obsolete anymore." Yes, it is, because you're not running the newest Wi-Fi drivers. Your Wi-Fi chip is not able to handle your current standard. It's really dictates how deep in the weeds you want to go with it. That's like, then you start getting like micro PCs and stuff like that. You start dealing with Raspberry Pis and stuff like that. 95% of Raspberry Pi runs on a firmware. Your greatest idea of the personal computing firmware is going to be Unix or Linux. That is because you still have to update an INI file, your config file and stuff like that. Inside that system, for it to work correctly and talk to other things. So by factory defaults, it's already blocked out everything else. It communicates with itself, and that's it.
Yeah. You get to the point that I was going to step into next. We see the OT side, we see the IT side, and both of you actually, funny enough, mentioned something similar, and the exact same thing I was going to is the security of firmware, and I know we're kind of getting deeper into a rabbit hole, but so if firmware is as important as it is what dictates what your machine does and controls how those communicate, then it just kind of goes to say how important that security now becomes. Those and Ed, you kind of touched on it, is that things change. You get new updates. So Nick, how often do we have updates on applications? Yeah. They're everywhere every other week. It's nonstop. Sometimes every other day. Yeah.
And sometimes you get parts of your firmware that you don't like.
Yeah.
A lot.
Yeah.
For example,
Windows 8.
That's definitely one.
The whole OS.
Yeah.
There you
Vista
go.
wasn't as bad as freaking.
You give me 98 back.
I'll take 98 over Vista.
You give me 98.
I'll take XP.
Yeah. Okay.
Valid point. That's what I had when I first came to the Marine Corps. So we went from Vista to 7 to 10. However, that's also I spent most of my career in security. Yeah. We won't go too deep into those weeds. However, with that, the old Lenovo's, the TI-89s, they used to have a feature called Phone Home. So the CPU would phone home back to Lenovo headquarters and let them know what's going on with their firmware at all times. However, no one knew it was in those data packets.
Yeah, I don't like that.
And if we're using our PCs in clandestine environments or environments that you're having to handle classified material or secret, company material and stuff like that, you're not wanting to phone home.
Yeah.
So at that point, we realized that you had to open up the machines, you had to cut a couple wires to the motherboard to prevent it from that firmware taking effect and phoning home.
Yeah, that's some LoJack stuff.
Eventually, we finally decided to destroy all of them.
Yeah.
Because it's easier that way. If you can still find a TI-89 in the wild, then, a old government version of the TI-89 in the wild, you might be onto a gem because those things were darn near indestructible.
Yeah.
It's not like the Panasonic Tough Pads, which those things are indestructible. The netbooks, the versions.
Okay,
the tablets themselves aren't indestructible at all. We've broken a few of those.
Let's say you lose to a forklift 100 times out of 100.
Right, but the laptop, those things, they're great. In the old Marine Corps way of a reboot, drop on the floor a few times, we'll restart. It's just the gel goes away after a while. But yeah, if you're talking about firmware and stuff like that, sometimes the firmware on board something can be caused to do something it's not supposed to do.
Yeah.
Or something that you don't expect until you actually watch your network traffic, because God knows how many times things phone home. Everything that is built is designed to phone home.
Yeah.
To give their support requirements.
Yeah, and that gets like, honestly, for most people starting out in 3D printing, there's going to be no phone home. There's going to be no connection to the internet, to be honest, and you're slicing to an SD card and inserting that. But if you get into the place where you're controlling it via Octopi or some other interface, connecting it directly to your computer to run, then you're introducing it into the world that Nick's talking about. The possibility for a vulnerability, for an attack, some cyber side, things like that. But I'm gonna take another step here, because we can probably talk cybersecurity all day too, and that's probably an episode in and of itself. But I'm gonna go ahead and dive into the 3D printing firmware. So from your guys' standpoint, I think that you've only experienced Marlin, right? You haven't really experienced much else besides.
Yeah, I pulled down a few others and play with them.
Right.
I'd not installed them, but looked through the config and the INI files, because I kind of want to see what they were dealing with.
Curious, yeah.
When you realize there's 10,000 lines of code, and your favorite print is Control F.
They're they're pretty similar, though, to be honest. And what I've learned is that the reason that they're so long in that sense is because you can comment out your motherboard, and you can comment out maybe what sensor that you have, and you can personalize that. It'll still be that flavor, let's say, quote unquote, that flavor of firmware, but then that flavor is tailored to your printer. Yeah,
you can have it say the Vulcan, and stuff like that, and stuff, whatever you want to have it say.
So. But yeah, Marlin's going to be what you start on. Marlin's going to be, that's Marlin 1.0. It's a version of RepRap, which was like one of the first firmwares, which is just, it's funny because it's rapid prototyping is what it's named after. So, which makes sense, comes full circle. The whole point of some of the 3D prints that you see in a lot of the manufacturing world is almost solely geared towards rapid prototyping. So, like, on that side, I there's a few others that you can go to. Personally, I have I just put the Easy Able Pro on it, and that's E3D's sensor. So I decided to go with E3D's Unified 2 software. I'm not going to say it's bad, because it's not bad. It does the same thing as Marlin, the same capacity. It's not as flashy in the icons or anything like that, but it gets the same point across. I didn't have to change my slicer. Everything is getting read the same. It's compatible. So that's the beauty of it. Some of these other manufacturers are going to have their own firmware. Like Anycubic has their own. I'm not sure what it's called. Prusa has their own, as well as each one of these probably have their own filaments as well. So they develop these things, and realistically, you could develop your own if you wanted to.
Yeah.
You just got to be able to write that code and understand what's calling to what. But one firmware that I wanted to kind of focus or kind of bring up is Clipper, because it's got the high attention to detail, or the high accuracy that you would probably want. But I'm going to be honest with you, that's not a beginner firmware. You're not going to, it's going to give you so many more details than, if you're a beginner and going straight to Clipper, you might get overwhelmed. There's too many details for you to be able to adjust. So I suggest Clipper for an intermediate or advanced printer. hobbyists or anything.
And they
like
also
that.
have a different version than using Octoprint and Octofarm. They have their own proprietary version of that, and that's what they would use to communicate. Yeah.
Yeah, so there are a few other versions. I'm just most familiar with Octoprint and kind of use that as my base example. But a lot of them probably exist in the same way, connect via API, and you use the cloud to send your prints from your computer over, or if you want to hardwire it, you can. But firmware dictates what your printer does, how it behaves. So it's going to be something that you should focus on. And those brands, if you haven't heard, or those firmwares, if you haven't heard about those, I suggest taking a peek at them. Like if you have Marlin that comes right out of the box on their stock, you can stick with that for a while. It's going to work. But if you end up getting an LCD screen, you want to make things look a little bit prettier, or you can effectively make an Ender 3 Pro into a V2 with a motherboard and a LCD screen swap. But that's if you want to. Honestly, at that point, you should have just bought the Ender 3 V2 because you're probably going to spend more money for that. But it's something you can do.
Like I just actually looked up what I was thinking about. It's called Mainsail.
Mainsail?
Have you seen it yet?
I have not.
Since we're talking about, since you have your laptop sitting right in front of you, look up Clipper Mainsail. And because this kind of deals with your firmware, it's how you interact with your firmware. Since not every, and the reason why I say that while you're looking it up, is not every single, interface to your firmware is exactly the same. You know that, Ed, from the OT side. Not everything is going to be identical.
No.
And I couldn't tell you, and me have been in the same situation where you open a box, you have 9,000 different connectors. Because for some reason, not everybody wants to go the same one. But what does it all go back to? The same exact interface.
And each type.
Yeah, it's incredibly detailed, actually.
Each type is going to be slightly different also. I mean, the big thing with firmware is... when we're talking IT and OT, IT live in a world of minutes. Mm-hmm. OT live in a world of seconds. So when we say we're going to do a firmware upgrade on the OT environment, you get hell no. Mm-hmm. When we say we're going to do it in IT, it's been planned and it's going to be down for that time.
Yeah.
We got all the parties involved. We came up with a strategy to tell you what's going to happen. We've got a plan for how it's going to for what's going to happen, when it's going to happen, and when we're done. And we got a mitigation strategy in place just in case something happens. And we tested offline too. Yeah. So I mean, that's in our backup environment. That's some of the things I think about with firmware. So, but you can always go back. Yeah, you can always revert. Yeah, the good thing with firmware is, okay, I have a problem. Maybe this firmware upgrade will fix that problem. But if it doesn't, then if I'm not having any issues, I can leave it. But if I do, roll back. Now, I say that, and I'm going to piggyback over that because when I first got my printer, there was, I was having multiple issues with, just different pieces and parts not doing what I wanted to do. So I thought, okay, maybe there's a bug. Because I also came from the software testing background and server and software and system administration and stuff like that. So the first thing I do is I kind of look for some unwanted and unplanned features, And I thought, well, crud, I got a darn unwanted feature, and I don't want this friend no more. I'm missing this thing back. Okay, it's got bad tomato. So I was playing with it. I think I reflashed my firmware on that motherboard probably 14 times, thinking maybe something's wrong. No, it's just I was dumb, and I didn't hit the right button on something. So I said, okay, cool, whatever. But I reverted back to stock. Then from stock to up 1, up 2, up 3, up 4, all the way to where I was now. And finally, I was like, okay, cool, I finally got it working. Yeah. You never know what you're going to get.
It's definitely trial and error for firmware. I started out with, the same firmware that you have, Marlin. It was like 1.0.2 or something like that. And when I upgraded my motherboard and got a BL Touch, I pretty much had to go to another firmware. So if you're adding a sensor or adding a piece, you're going to need to either rewrite or add to your firmware, which in a lot of cases not a lot of people know how to do, or you're going to have to get new firmware. look for newer versions or things like that. Marlin 2.0 definitely had those things I needed, but there's also firmware that's like kind of, you know, similarly like how most things kind of branch off of Marlin, and you know, Marlin branches off of RepRap, but it branches off of Marlin, and it's called gyres. And a lot of people have probably heard of gyres. It gives you so much more, you know, of what you were showing me on Mainsail with Clipper, so much more that customization, and you can visualize your print bed, and you can see if it's warped. Like, you can see if it's like, hey, this is completely level. Prints are completely level, but you look at the mesh level that, you know, was measured by that BL Touch, and you'll see that, like, it is not flat still. You know, and even with Clipper, like, that's actually another good example. Clipper does this thing, I think actually is with one of the newest updates, where it will tell you how many turns you need to make on your knob of your print bed, and what direction, counterclockwise, clockwise, how many degrees you need to turn it to get it to be as flat as possible, so that your probe, or your ABL, or whatever your auto bed leveling, you know, sensor is, doesn't have to do all of the work. And honestly, like, it'll probably fix it, but like, you don't want it to do that much work. You're gonna wear it out. So, like, personally, Marlin should be your starting point, you know, and then eventually stepping into Clipper, I think.
Yeah, that's where I think once I upgrade my motherboard, that's where I'm gonna go hang my hat at for a little bit. Yeah. You know, and dink with that.
I think it's cool too, because, like, I mean, you have C+ and C like knowledge. Like, if you're a programmer, ever programmed anything, you know, I mean, honestly, if you know one language, it's not that you know all languages, but you understand how syntax works now. Yeah. And that you may not necessarily know what the term is, but you get it. And I need this, I need a space, and then it tells you this is the type of command I'm running in that subset, so on and so forth, and I'm calling back to this variable. Yeah. And then you can make it yourself.
And the thing is, I will say this, if you're doing that, especially if you're using Visual Studio of any level, tab complete is your friend. You can tab complete through a lot of code. It's the same thing as what you start dealing with. If you start dealing with Linux, everything is, you know, cd dot to cd to slash to the tab complete. However you're getting there, you only need a couple letters.
Is that commenting out, or is that
you can do with it
compiling?
It's tab complete. What I mean by that, it's like if I know that I want to map something to something else, I hit the tab button, it'll complete my sentence for me. Okay. So it takes care of all that syntax, and it'll map it back to something else. Okay. So commenting out, usually, especially if you're dealing with like Python and stuff like that, you know, you'll select it, and then it's like a Control Shift / and it'll comment out an entire section of code for you. So you don't have to go back and do that.
That's one of my favorite features. When you showed me that the first time, I was like, I need this.
And the thing is, you know, there's a little bit of a trick, because the problem is, even if you comment out something, your motherboard still has to read through it. Yeah. Is if you don't need it, delete it. Yeah. Because the problem is all you're going to do is speed up your process. If you delete 95% of the crap you don't need, and then you go to a lightweight, you can still take Clipper and make it as lightweight as morally possible by deleting everything you don't need. It's not like it's tied to anything, right? It's just settings at that point.
Yeah, it's just reading a configuration file.
And so you rip those out of that configuration file. Now you don't need it anymore. It's still going to read through and go, nope, I don't need to worry about that. Nope, I don't need to worry about that. Nope, I don't need to worry about that. Oh, hey, look, I found my sentence I need. You know, why not cut out most of the fluff and speed that process? Even though the new motherboards are 32-bit anyways.
Yeah, they're gonna be able to process a little bit better, but still.
Actually, now you have the 64-bit ones you can play video games with.
Oh no!
On the printers. Have you seen those?
I don't know if there's any 60. Well, okay, commercially at least on my level, which, you know, I'm just saying like the $200 to like $700 range. Ain't no 64-bit printers right now. So if you want to spend a couple $1,000s, you might find one or two here. You might get that Formlabs one, and it's I think that's actually resin, but you know, it definitely has their own proprietary firmware. I'll tell you that much. But
the funny part is, it's actually on a motherboard.
What's that?
You can play video games on a 3D printer motherboard. Because it's got that, and it's...
Can you get a little bit of RAM, I'm guessing?
Well, it's the upgraded version for mine.
Oh, okay.
So, well,
the 4.2.7?
No, not 4.2.7, but the other version that we were
SK2.
Yeah, SKR2 or something like that. The Mega.
The one from Big Tree.
Yeah, Big Tree. The Big Tree Mega.
Okay.
The very big large one that can do it.
Yeah.
And those really aren't that expensive.
Yeah, no, that's not.
I'd love to put a Mega in mine. I got plenty of space in there to do it, but I have to modify the case. I can put an SKR Mini 2 in there.
Yeah.
And be perfectly fine.
But that's the beauty of 3D printing too. Is like, that's what you could do that. Like you're like, my case isn't big enough. I'm gonna print a bigger one.
But the other thing about that, and Ed, you'll enjoy this, with the Megas, you get the serial port. The serial port comes back on a 3D printer, and it's not the one that we think about as the square one.
Mm-hmm.
The one that we all thought was dead, long time ago. Nope. Guess what you get? Chinesium. And back comes the relic of
I know what you're talking about.
The PS2 ports.
Yeah. It looks like a
inverted
like
square
a printer.
Yep.
Connection. Yeah.
Yep.
So the Anycubic Chiron has that.
Oh, really?
Yeah, the Tri-Gorilla is 0.0.2 board. It has that. Now, pretty sure that's still 8-bit board though.
Yeah. But that's how you would interact with your firmware. Because what you do is you do that and you'd access it via the CLI, and then up it comes.
You flash at that. See, okay, so I want to kind of go back actually to the VS Code that you were talking about, because I want to say something about compiling things. Like, if you don't have a compiler installed on VS Code, you're not going to get your firmware.
Nope.
100% you won't get your firmware. You need something that's going to compile that machine code or that programming so that your printer can read it, and it'll create it in a firmware file so that your printer will be able to understand what you're putting in.
And you don't have to use just VS Code either. You can go out and use
it's just easier
pure Visual Studio.
Oh, okay, Visual.
The 100% Visual Studio. We run a lot of Visual Studio Professional and VS Code on top of it. It's like VS Code is really good for like TypeScript, amongst others. Something that's like really flashy. I call it a grown man's Notepad++.
That's true, because I was gonna say Notepad++, but it does not have. Once I found this VS Code, Notepad++ isn't used as much anymore. I'll tell you that much. But I kind of want to get your thoughts, Ed. We're talking a lot on the software side. A lot of that firmware is dictated and dictates what the hardware does, right? But I feel like we've heard you several times about it should do this, it should do that, it should do this. That could be changed in the firmware. So, honestly, on your side, there's mechanical changes that you could make, but what are some mechanical changes that you probably wish could be fixed with like a firmware? I feel like we've talked about it before. There's like, what is that? The Bamboo has LiDAR. Mm-hmm. Like that's beautiful in the firmware, and that's beautiful with how it's measuring your flow rate. But any other cases you could think of?
Well, I think we could probably do something with the extrusion fans, as far as the speed. Maybe there's a print where we're blowing too much air, and that affects the actual print.
Oh yeah, 100%.
Yeah, I think you can do things like maybe you could also the motors that you're using. Maybe you could eliminate a motor with firmware and hardware. So I could save on a motor by using a different type of mechanism for that. And then I guess some of the other things if you just into HMIs, you can maybe change the HMI or get creative some kind of way, and instead of using the onboard HMI, maybe you can turn a tablet into your dashboard or something like that. Yeah,
because that's honestly kind of what I'm getting towards. Is like you made a list already, right? That's how easy. Okay, maybe not. I shouldn't say easy to innovate, but that's how innovation starts, right?
That's how you ended up with Octodroid.
Yeah, and we talked about it. We were talking about it earlier. servos instead of the stepper motors.
Mm-hmm.
Now you can get those wired there, and you just got to do a little firmware change, and honestly, it might even read the same firmware. So some of those things that you if you're on a mechanical standpoint or a mechanical side of the board, you can. All you gotta do is just shoot a question to the people on GitHub and say, "Hey, I noticed this. How do I do this?" And they are wonderful. They will help you solve your problem. If their firmware doesn't work, they'll work with you on why their stuff didn't work. Mm-hmm. So like we talked about, the community is important, and that's kind of where the innovation also mm-hmm. comes from too, because we're making it better for each other. So I also would add, I think we've talked about it before, Ed. A bit more of like the pulse width modulation with the power supply. Now you said the power supply is a good power supply, but maybe I can control I can control some of those failures, or have it like save a print or something like that with some type of firmware setting, right? Or some type of sensor that I plug in where it's like, oh, you've gone over a certain temperature, cut the power. Right, something like that. Mm-hmm. Now that's definitely a place that like I would take it as far as trying to innovate. I mean, you can innovate. Like Clipper's done a great job, and Formlabs too. Like we looked at that printer the other day, but
it's worth the money.
Yeah, it's definitely worth the money. I'm probably gonna get one eventually. This is on down the line. That's expensive.
Yeah, I'd love to have $5,000 to blow on a printer.
Yeah. But you ever wonder why your car went missing? Had to sell something, right? No. But yeah, no. Those are the things. Like it takes like the thought of like why are we doing this the same way to innovate? Like I feel like I've brought it up every time. The pancake bot. You just changed one or two parts, and you've made an entire new machine. The farm bot we looked at is a CNC machine remake that like farms for you. It's mm-hmm. There's so many innovations that you can do with this. It just opens the doors, and that's really what we want to kind of get to and kind of teach you that like this is a start, but don't let this be the end.
Learn it, have fun with it.
Yeah, it's as easy as like I don't like that. All right, well, what would you do?
Yeah.
So you start your scientific process there, and you got your own project. And then about 5 months later, you can call us, and we'll try to help you put it back to how it was.
Yeah, pretty much. Mm-hmm. And I think with that, I think we'll probably find another version of firmware we'll get to. As we play with them, we'll talk about them. So I think as we load new firmwares, as we investigate the next firmware, like for example, we can talk about the 4.2.1. At a later date, because that's what I got on mine. What's changed between what's on the current, the 1.1, the 1.0.0.1 that is currently on the Ender 3 Pro.
Marlon's gotten to like version 4 or something?
Mine's 4.2.1, yeah.
Oof, okay. Well, I need to probably go back to Marlon and try it out and see what they've changed.
Yeah.
Because I don't think I've touched it
the thing, well, there's a little bit of a spoiler. The one thing I learned, when you went to that 4.2.1 on mine, I also have print auto restart.
Oh, yeah.
So I go to that. I also have the ability to add a filament break sensor in there and stuff like that, so.
Yeah. There's a lot more you can do. Like, I mean, honestly, upgrades.
And also auto level because it's built for the CR Touch that's on mine.
Yeah.
So. But we'll get to that. We'll get down that road, here in a little bit because eventually we're gonna upgrade Ed's firmware, and then we'll do a quick comparison between the 1.0.1 and the 4.2.1, and then we might upgrade Ed's to the 4.2.1, and we'll see what happens with that. So, but we'll compare everything. We'll talk about it on the podcast. We'll probably talk about it on the YouTube channel too. But, that's, here nor there. But, I say thank you, from my side. I've been looking at all the statistics and stuff like that, and I really do say thank you. It's awesome. Everybody's making, me and Ed, think that we should have done this a lot sooner than we did. But, it is what it is. We're having fun with it, and we hope you all are too. We hope you all are learning something. And, at the end of the day, we don't care who you're listening to as long as you're learning something. But we're glad to have you. Thank you, and I'll turn it over to the guys for the closing words.
So you can think of, if anybody plays video games, especially retro games, or played retro games before it became retro games, they had game genies that allowed you to do cheat Game Shark, but it allowed you to do cheat codes. So that's basically what firmware is. It's a way for you to add some functionality without actually having to rip everything out and redo it. Most of these systems are years ahead. When they plan them out, they already are adding some features, to it. They just don't force them onto you. So that's the advantage of upgrading firmware or not.
Yeah. So the last things that I kind of want to touch on, so firmware don't let it. It sounds crazy. It sounds like difficult, right? It sounds complex, but it is not as hard as it sounds. And there's plenty of people who have already gone through the hardships so that you don't have to. So if you're going through and doing your own firmware or implementing or configuring new firmware, just do your research. That's all. Read what it does. Read the most recent patch releases and see what's going on. That'll tell you if you want it or not. Tell you if you're wasting your time or not. And honestly, we'll tell you if you're wasting your time or not. So you can just ask us. Use your resources. So. And
if you're on GitHub, you can see the current bugs.
Oh yeah. Believe me, they're working on it all the time. I see patches all the time. I'm just surprised they got the version 4. I just think that it was still going to be the same version, just constantly new releases.
That's probably what it is. They probably got tired of doing the update.
Yeah, right. I think they did went official with it at some point though, and they made it. This is the official firmware.
They actually put a new date on it, so that's most.
Yeah. But we'll get back into that if
it's a different rabbit hole.
Again, thank you. Thanks for listening. We're always appreciative. So, from all of us here, thanks.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.